Hey guys, Farron here. We're going to go ahead and look at parent functions and their transformations today. So we have these basic functions where when nothing else is happening to them, we're not adding and subtracting anything. It's just the square root of x or the x squared. Nothing else is being done to it. It has this shape and we call those parent functions. Okay, they never change. So we're going to look at what some of those parent functions look like, and then we're going to use those to then move them left, right, up, down, stretch them, shrink them, flip them around, all of these fun things. So first parent function we're going to look at is f of x equals x squared. Okay, when I'm looking at this, I know that I'm going to graph using this table, and we've kind of already looked at some of these. Remember, most of the time the x values I want you to use are -3 to +3. Okay. And if you really, really want to, you could plug this into your calculator and get the table. But when we're doing parent functions, it's very easy to kind of plug that x in and figure out what that y would be. So -3 squared is going to give me 9. 2 squared is going to give me 4. -1 squared is 1, 0, 1, 4, 9. And I can plot those points. So 1, 2, 3... 1, 2, 1, 1. Okay, so it's going to give me this shape, and we know this. This is our parabola, right? Our x squared is our parabola shape. It's that U shape. So now we're going to look at domain, range, increasing, decreasing, all those things that we've looked at before, just to kind of make sure that they stay fresh in our brain. So when we're looking at domain is our x values. Okay, when I'm looking at the x values that I currently have, I have these arrows that go forever and ever and ever up. And remember, they're going out. They're always increasing out a little bit as well. So when I'm looking at my x values that I have, I am going all the way from -infinity to infinity. I don't have an x value on the left or an x value on the right that I will ever hit. I'm hitting every single one of them. Range now. Range is my y values. Okay, my y values, we talked about the lowest point to the highest point. So when I look at this, I do have a low point right here. But again, those arrows are going forever and ever and ever up. So I will never get to a high point. Okay, so that low point, we are going to include that low point. That low point is at the y value of 0. Okay, and then again, since we're never hitting a point, we're going to go to infinity. Increasing and decreasing now. We're reading it from left to right. And we're going to tell what it's doing from left to right. So the first thing I see from left to right as I'm looking at this thing is it's starting all the way up here. And as I go from left to right, it's going down. It's decreasing and it stops right there. That's the point where it shifts and then it starts to increase again. So I need this first interval right here to show me that I am decreasing. So I'm starting at -infinity and I'm going to 0. Now remember, when we're looking at increasing and decreasing, we're looking at our x values again. Okay, so I'm decreasing when x is -infinity all the way to 0. And we don't include these for increasing and decreasing intervals. Then from 0 all the way to infinity, I start to increase. That graph starts to go back up again. There is never a point on this graph where it is a constant, so I won't have anything there. And now symmetry. Okay, symmetry is going to tell us whether we're odd, even, or neither. Okay, so odd, remember, has symmetry around the origin. If I take it and I flip it around the origin and it lays on top of itself, it's got odd symmetry. Even is your y-axis. Okay, so when I look at this, if I take this graph and I flip it over the y-axis, it's going to lay on top of itself. So this is going to be an even function. Let's go ahead and look at our next parent function. Our next parent function is going to be y equals the absolute value of x, or f of x equals absolute value of x. So again, I'm going to use -3, -2, -1, 0, 1, 2, 3. I'm going to plug those in. So -3 is going to give me +3, -2, +2, -1, 1, 0, 1, 2, 3. And I'm going to go ahead and look at these, plot those points. And I know the absolute value of x is going to give me the V shape. So these are going to be straight lines now. So let's look at the domain and range. You're going to notice, you guys, this is very, very similar shape to that parabola up there. So that domain and range, even that increasing, decreasing, it's all the same, right? My parabola had those arrows that were going up and out forever. Well, my absolute value also has those arrows that go up and out forever. My parabola stopped at 0. It also stops at 0 here. So my domain, x values, I'm going forever and ever and ever out both directions. So we're going to go negative infinity to infinity. Don't ever include those infinities. Range, y values. The lowest value I have is a 0. I'm going to include that. And it's going forever and ever and ever and up. So it's going to be positive infinity. Increasing, decreasing. As I read this from left to right, I'm decreasing from negative infinity to 0. And then at 0, it changes direction, and I'm going to start increasing all the way to infinity. No constant ever happening. And then if I flip it over the y-axis, again, it lays on top of itself. So this is an even function as well. Okay. Next parent function we have is the square root function. It's the square root of x. So when I'm looking at this, I'm going to create this table. Now, normally we want to do -3 to 3. But when I plug in negative numbers to a square root, it's going to give me imaginary numbers. So I can't do that. It's undefined. We can't find those and plot those. So then I could plug in positive numbers. 0 square root of 0 is 0. That's good. So we could use that one. Square root of 1 though is 1, but square root of 2 is going to give me some decimal point, and that's not going to help me create this nice shape that I want of this graph. So when I do the parent function for the square root, I only pick numbers that I can actually take nice square roots of. So when I think of this, I can take the square root of 1, I can take the square root of 4, and I can take the square root of 9. So these are going to be the 4 x values I'm going to use that are going to help give me the nice original shape of this graph. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. We can plot those points then. Okay, now the square root function is like a curved half of a parabola. It's like we took the parabola and we flipped it on its side, and then only took half of it, the positive side of it, because you can't, again, take the negative square roots of numbers. So when we look at the domain, the left and the right. So in this specific situation, I do have a starting point. I start right here at this x value, and it goes forever and ever and ever the positive direction. So I'm starting when x is 0, and I'm going to include that. And it's going the positive direction, so I'm going all the way over there. My top and bottom is very similar, you guys. I start right here. That's the bottom of it. And that arrow is going out and up. So I'm starting at 0, and I'm going to infinity again. Increasing left to right. Well, here it starts, and it's only ever increasing. So I'm increasing from 0 to infinity. Never decreasing, never constant. Now, look at your symmetry. Symmetry over the y-axis, if I take it, there's nothing on the other side, so it's not going to give me symmetry on the y-axis. Symmetry around the origin. If I take this thing and I flip it, okay, take this thing and I flip it 180 degrees, it's now going to lay down here. There is nothing down here. There's no graph down here. So again, I don't have any origin symmetry. So this is a neither function. This is neither odd nor even. Okay, this is our last parent function we're going to look at before we start to look at some transformations. So I have this graph x, y. So when picking x values for this, we are going to go back to the -3, -2, -1, 0, 1, 2, 3. This is not going to give me really nice numbers because it's a fraction, but no number I put in is going to give me nice numbers. So we're going to deal with these and do our best for this. When I do 1 divided by -3, I'm going to leave it -1/3. I don't want decimals, so leave them as fractions. 1 divided by -2, -1/2. 1 divided by -1, -1. 0, 1, 1/2, 1/3. Okay, so we're going to plot these as nicely as we can. They're not going to be perfect, and that's okay. And then we're going to go, oh, I want to change one though. When you plug in 1 divided by 0, this one I should have cut. 1 divided by 0, we cannot do that. Can't do that. So this situation is undefined. That's an undefined. And we'll talk about what that means here in a little bit. So we're going to have 1, 1, 2, 1/2, 3. If you were to graph this in your calculator, it's going to look something like this. Okay, and what this means is we are undefined on those axes. That means this graph gets super close to those axes, but never actually touches them. So there is no value when our x is 0 or our y is 0. And that matters when we're talking about our domain and our range. And so that's going to change things a little bit. When you're looking at your domain then, I have all negative x values and I have all positive x values, but I don't have anything at 0. So we cannot include our 0, and we have to write it like this. We have to write it -infinity to 0, not included, but then we pause and we go from 0 to infinity. This tells me we're not in the middle. There is no 0 happening, okay? When I do the range, it's the same way. I have all negative y values and I have all positive y values, but I don't have any y value at that 0. So we're going to have to split it into 2 different parentheses. Now let's look at this. As I read this from left to right for increasing, decreasing, I'm starting here and it's going very slowly down. So I'm decreasing there. Continue reading this. I then jump all the way up here, but I'm up here. And if I read it from left to right, I'm still decreasing as I go down. So it's how your pencil's moving as you're actually moving. Even though I had that big jump, I'm decreasing for both of these. So 0 increasing happening, decreasing still from -infinity to 0, 0 to infinity. Okay, so take some time to process through that. My constant, I don't have any constant here. But here, let's look at this. If I take this graph right here and I flip it 180 degrees, it's going to bring it down here. And it would lay exactly on top of that one. Okay, so this one is one where it is symmetric around the origin, which tells me it's going to be an odd function. Okay, so now we've looked at those parent functions. Now we're going to look at what happens when we take those parent functions and we add specific things to the graph that tell me to either move it up, down, left, or right. That's all we're going to focus on today. So you're going to have some things where it's happening inside the function. Okay, so see how whatever is being added or subtracted is happening inside the parentheses or inside the function? That's a special case. In math, when it happens inside the function, inside lies. Okay, so it is not doing exactly what we would think it would do. So when I looked at that first one, f of x minus h, to me the minus h would tell me I'm moving left the h value. But it's inside the function, so it's lying to me. So this one's actually going to move right that number that it's adding or that it's subtracting. The f of x plus h, okay, I would think it's telling me to go to the right because it's plus, but it's inside the function, so it lies. So I'm actually going to go to the left, whatever number's there. Now, when it's happening outside the function, so that k value is happening outside the function, that's going to tell me up or down, and it's exactly what I would think. So if it's plus k, I'm going up that value. If it's minus k, I'm going down that value. So let's go ahead and look at just some examples of this before we graph them. So it says state the parent function and then explain how it's being translated. So the parent function without having anything happen to it is the square root of x. Okay, so my parent function is the square root of x. Now we're going to look at what's actually happening to it. So inside, it's adding 3. Remember, that's lying to me. So I would think it would go right 3, but it's actually going to go left 3. Okay, outside the function is exactly what we would think it's doing, up or down. So it's -5, so it's going to tell me down 5. Let's look at the next one. Okay, parent function without the adding and subtracting, it's the 1 over x. So my parent function is going to be 1 over x. And now let's figure out how it's translating. So inside the function, it's got a positive 2. Inside lies. So I would think it would be going right 2. So it's actually going to go left 2. Outside is exactly what we would think, and it's up or down. So positive, up 1. Last but not least here, let's go ahead and look at this last one. We got parent function. Parent function is going to be x to the 2 power, so my x squared. So parent function is x squared. Now let's look at what's being done to it. So when I look at this inside, I'm subtracting 7. That tells me right or left, but it's opposite of what I would think, so it's going to be right 7. Outside, exactly what I would think. So it tells me down 1 because it's negative 1. Okay, so now we know how to read what is happening. Let's go ahead and graph what's happening. So the way that we're going to do this is we're going to find the parent function, we're going to tell what's happening, and then we're going to graph exactly what it's telling me to do. So parent function. Parent function of this is going to be the square root of x. Inside the square root function, it's got a positive 1. That's left or right, and it's opposite of what I would think. So it's going to go left 1. And then outside the function is exactly what I would think, up or down. So it's going to go down 1. So what I'm going to do is I'm going to think about my table for my parent function of the square root, which was 0, 1, 4, 9, and then 0, 1, 2, 3. So I'm going to graph that first. 0, 0, 1, 1, 4, 2, 9, 3. Dotted line for this one. Okay. And now I'm going to graph the translated function. So I'm going to put my dot, or put my pen on the original dot, and I'm going to move it left 1, down 1, and I'm going to get a new dot right here. I'm going to go left 1, down 1, new dot. Left 1, down 1, new dot. Left 1, down 1, new dot. So I'm starting on the original dot, okay, that I had from the parent function, and I'm doing whatever the translation was. So left 1, down 1, there's that new one. Left 1, down 1, there's that new one. So it's going to be the same exact shape, just shifted down. All right, let's look at this one. So parent function here is that x squared. Inside the function is lying to me. So I would think it would go left 1. It's going to go right 1. Outside the function is exactly what I would think. So it's going to be up 2. So here's my original graph, -3, -2, -1, 0, 1, 2, 3, which gives me 9, 4, 1, 0, 1, 4, 9. Okay, it's a parabola shape. So I'm going to plot those originals first. -1, 1, 0, here we are. Dotted line. Okay, and now I'm going to do exactly what it tells me to do. So I'm going to put my pen on original, and I'm going to go right 1, up 2. So I'm going to go right 1, up 2. Right 1, up 2. And I'm going to plot all those points. So right 1, up 2, up 2. Right 1, up 2, right 1, up 2. Right 1, up 2, right 1, up 2. Here's my new translated function. Same shape, just shifted over. All right, last but not least, I have this parent function here. Parent function is the absolute value of x. Okay, I know that that's going to give me -3, -2, -1, 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 3. Okay, I probably write out more than is necessary, but it just helps me keep everything straight, and especially when we get into future days, I'm going to write out everything so that I can keep track of what I'm actually doing with all these translations. Today, it's pretty easy. So I'm going to look at what's happening. This +4 is happening outside the function. So it's exactly what I would think. It's telling me to go up 4. So I'm going to take my pen. I'm going to put on each single dot. Oh, I got to plot the original first. So I have the original, which is the absolute value V-shaped dotted lines. So now I'm going to take my pen and I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Okay, and I'm going to create that next shape, which is just the same exact thing shifted up. All right, you have an assignment to try. Answers are online as well. Reach out if you have questions. We will kind of talk through a little bit more of this tomorrow, as well as adding on to it. So make sure you're not falling behind.